Afbau's principle. Aufbau is a German word which means building up or construction. The definition states that the lower energy orbitals are filled first. To understand Aufbau's principle, let's first understand about electronic configuration. Electronic configuration. It is defined as distribution of electrons of atoms or molecules in atomic or molecular orbitals. Atomic orbitals are in substationary state when the electrons revolve around them. The electrons are in the principal energy levels such as n equal to 1 and so on. This diagram shows how the electron revolves around the orbitals of lower energy to higher energy. Principal energy levels and orbitals. The principal energy levels are further divided into sub-energy levels like n equal to 1, 2, 3, 4, 5, 6 and 7. These are further divided into 1s, where s represents the spherical orbital. Two is divided into 2s and 2p. 3 into 3s, 3p and 3d. 4 into 4s, 4p, 4d and 4f. 5 into 5s, 5p, 5d and 5f. 6 into 6p, 7 into 7s and 7p. Now let's see how many orbitals are there in each sub-energy level. S has 1 orbital, P has 3, D has 5 and F has 7 orbitals. One orbital has a maximum capacity of only 2 electrons. Therefore, S orbital has 2 electrons, P has 6 electrons, D has a maximum capacity of 10 electrons, and F has the capacity of 14 electrons. Now, let's see how the electrons occupy these energy levels. To understand this, we'll have to draw out the energy levels again, like we're doing now. 3D, 4S, 4P, 4D, and 4F. 5S, 5P, 5D, and 5F. F is the last of the orbitals. 6S, 6P, 6D. 7S, 7P. The electron first enters 1s, then 2s, then 2p, then 3s, then 3p, then 4s, then 3d, then 4p, 5s, then 4d, 5p and 6s, 4s, 5d, 6p and 7s, 5s, 6d and 7p. Now let's see with one example. Let's take oxygen as an example. Oxygen is known to have 8 electrons. The electronic configuration is written as 1s2, then 2s2, then comes 2p, which has 4 electrons. Now let's draw out the orbital rotation for oxygen. We'll have to draw out the orbitals. We first draw 1s, then 2s, and then 2p. We then name them. The first electron enters 1s. The second electron, based on Pauli's exclusion rule, which states that two electrons entering the same orbital have opposite spins. That means the second electron which enters 1s will have opposite spin. The same is applicable to 2s. Then first electron enters 2p. The remaining electrons, based on Hund's rule, which states that each electron should have the orbital half filled before pairing up the other electron. Therefore, the electrons in 2p enter this way. Now let's see the noble gas electronic configuration. Let's take the example of scandium. Scandium has 21 electrons. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d1. This can be written as Ar18, 4s2, and 3d1, where Ar is the noble gas. There are many exceptions to Afbau's principle. Let us see it with two examples. Let's take chromium and copper. As two examples. Chromium has 24 electrons. The electronic configuration is Ar18, 4s2, and 3d4. When we draw the orbital rotations, we will see that one electron from 4s2 is moves to the vacant orbital in 3d. This is because the 3d orbitals are very stable when they are in their half-filled or completely filled state. Therefore, 4s2 becomes 4s1 and 3d becomes 3d5. That is, one electron from 4s moves to the vacant orbital in 3d. The similar is the case with copper, which has 29 electrons. The electronic configuration is written as Ar18, 4s2 and 3d9. To make it more stable, one electron from 4s2 jumps to 3d. Therefore, the configuration becomes Ar18, 4s1 and 3d10. This is like chromium, which has Ar18, 4s1 and 3d5. Thank you.